Good morning, everyone. I'm audible. Good morning, sir. So, after the last class, do you have any doubt, anyone? Any doubt after the last class? What you have understood after the last class? Okay, so I hope so. So, in the last class, what we have discussed, do you recall? Anyone? No. So, in the last class, basically, we have discussed about the universal joint, or also known as Hooke's joint. Okay, so we have seen there that basically this particular type of joint is used to connect two subs which are not parallel and but they are intersecting at a small angle. So there are the driven shaft and the driving and the driven shaft. They are connected by basically a cross piece, and the two ends of this driving shaft and the driven shaft were made like forked ends so that the cross piece can enter there. And now whenever the driving shaft is rotating, so from there driven shaft gets the motion. So we have seen its application to be in different transmission uh, shaft from the engine side, engine gearbox side to the rear axle, etc. Okay, and but we have seen that there was one problem, like we are not getting the constant velocity ratio. And after that, we have deduced one expression for the ratio of shaft velocities in case of your full change. So there omega 2 by omega 1 is we have obtained like equal to cos of alpha divided by 1 minus cos square theta into sin square alpha. So this omega 1 and omega 2, they were nothing but the angular velocity of the driving shaft, and angular velocity omega 1 is driving shaft and omega 2 is angular velocity for driven shaft. And that alpha angle was nothing but the angle which was there in between the driving and the driven shaft. And theta was the angle that was turned by driving shaft, okay, during a particular time. So then we have deduced the expression for maximum and minimum speeds for driven shaft. We have seen that basically it varies from maxima to minima, and we have obtained like minimum speed to be omega equal to omega 1 into cos alpha, and maximum is omega 1 divided by cos of that angle alpha. And we have also seen at some 4 point, basically we have also got equal speeds for driving as well as the driven stuff, and the condition that we have obtained as cos tan of theta equal to plus minus root over cos alpha. Whenever that is happening, it is condition is being fulfilled, and we get equal speeds of driving and the driven stuff in case of our hook shaft. Also, we have found out the maximum fluctuation of speed that is there in case of your wheel joint and the condition for it. So those things we have discussed, and later on we have seen that basically to nullify that problem of variation of your not having the constant velocity ratio, we are going for a type of modification of hook joint known as the double hook joint. So there we have discussed about double hook joint, how it is behaving, and that intermediate stuff we have seen that basically was one of the important thing apart from using two hook joints at both ends. Okay. So then we have discussed about intermittent motion mechanism, where we have studied about Geneva wheels and ball and ratchet mechanism. We've seen that depending on the frequency of intermittent, how frequently on the particular movement, continuous movement to the intermittent movement. So in case of Geneva wheels, we have to have that proper design of the particular slot rate wheel. Okay, so with a four slots, eight slots, etc., depending on the frequency, required frequency. And we have also seen the pole and reset mechanism, whereby we have seen that there in the case of pole and reset, basically uh, one way directional movement also is obtained, and other portion that movement is restricted. And about parallel linkages we have discussed in the last class. So with this, basically the theory portion we have covered from first model. So we'll try to today we'll see some two problem from the whole numerical. So we'll try to solve from full chain, and if time permits, we'll go for like one or two numericals from so another numerical from regular video, or maybe steering the impedance. Okay. So after this much, if you have any doubt in the module one, you can ask, because today we are going to finish it. No doubt here. Yes. If no, we'll move ahead. Okay. So all of you take out your pen paper so we can try a element. So now the fundamental equation of steering correct steering. So if you recall, we have seen that basically the cot minus cot theta equal to a by d, where this angle is also important. Right. Okay. So now today we'll see some. First, we'll try to solve one problem with your hook chart. Okay. So I hope my screen is visible. Let me know. Is it visible? I hope so. Okay. So now what does the problem statement says? It says that there are two shafts, okay, and with included angle is given as 160 degree, and they are connected by what? A hook joint. Hook joint is nothing but the universal joint that we're talking about. And it is given that the driving shaft it is running at an uniform speed of 100 1500 rpm. Okay, and with the driven shaft, basically it is carrying a flywheel of mass 12 kg, and its radius of gyration is 100 for the flywheel, which is attached where in the driven shaft. Okay, now let's consider find the maximum angular acceleration of the driven shaft. We have to find out the maximum angular acceleration of the. This is not known. This is uh, find out. You have to find out. Okay, of which of the driven shaft. Also, the maximum torque, assuming the shafts to be torsionally rigid. Okay, so torsionally rigid means basically whenever it is transmitting motion, rotational motion, so there will not be any twisting, and also it is called it is torsionally rigid. That is the case. Now, what is being given? So the two shaft included angle is 160 degree. So that means the what about the alpha? We'll be able to find out from here. So the two shafts you get something like this, and 160 degree is the included angle here. So basically the alpha angle, that is the small and intersecting angle that we are interested in, alpha will be how much? 180 minus that 160, that includes angle, and alpha equal to 20 degree. That is the angle between the two. It is given. Okay, here it is given. You can write down the given. Okay, and find given, and the intersecting angle alpha equal to, or angle of intersection alpha equal to 180 minus this 160 into them. Next, what is given? Your n is given. Okay, driving shaft n, or n1, you can say n1 is equal to 1500 rpm. It is given. Uh, and the driven shaft, it is carrying a flywheel of mass 12 kg. So m is given, flywheel mass equal to 12 kg. And radius of gyration is given as 100 mm. So k is given, k equal to 100 mm. In meter, if we convert it to meter, it will be zero point 0.1 meter. Okay, so these are the given data. Now, from here, what we can find out. So for the driving shaft, the RPM is given, okay, and is given. So we can find out the angular velocity omega 1 for the driving shaft. So how can I find out? We know that omega equal to 2 pi n by 60, that we already know. So for omega 1, it will be 2 pi n1 by 60. So n1 is given as 1500. So we are just putting that particular value, omega 1 equal to 2 pi into this 1500 rpm divided by 60, which gives rise to 157.07 radian per second. So these units are important. Okay, so use the proper unit, because if you use wrong unit, you will lose some marks there. So that is the angular velocity of the wheels. Now you see, in that particular case, this flywheel, okay, the flywheel is attached to. Do you know about the need of flywheel? Generally, why it is used? Flywheel, use of flywheel. Anyone? So basically, it's actually cyclic variation, which is generally there in a cycle. Okay, to reduce that particular cyclic variation on cyclic variation speed, we actually use the flywheel. So flywheel, due to its mass and inertia, it basically stores up certain energy Okay, and whenever required, it actually releases it. So about flywheel and its working, we'll be studying in more details in, I think, machine design and dynamics, that particular subject. But right now, you must know that this particular flywheel is there, and I believe all of you already know this expression, inertia. Okay, so I equal to mk square here. All of you have already from your engineering mechanics also. Okay, so all of you already know that this expression, this is the standard expression. Okay, so from here, what I can find out, m is already given, radius of variation is given. So mk square, m is 12 kg, k is zero point 0.1, zero point 0.1 squared. So what we are finding, so we are getting I to be equal to 0.12 kg per meter square. Okay, so this value, it will be required ultimately, because see, oh, what is being asked, why you are finding this out. It's not like arbitrarily just we are finding out. So at the end, you should be able to find out maximum angular acceleration of the driven shaft as well as the maximum torque. Those things are required, right? Okay, so torque is rotational equivalence of whatever is in linear case, linear motion, whatever is force. Okay, so in case of your rotational motion, it is torque. Okay, tau or t also sometimes. Okay, it is having the same effect. So it is going to rotate it. So F equal to ma, I believe all of you already know in case of linear motion. Yes, some of you may respond so that I can know that yes, you are alive. Yes. Okay, thank you. So can you tell me, will you be able to tell me the analogous expression for rotational motion, just like F equal to ma, all of you already know, mass into the linear acceleration, t or tau, how, what, so what is the rotational equivalence of this mass in case of rotational motion? This I, yes, and this is the linear acceleration. So now we have to find out angular acceleration. Angular acceleration means, what is the standard symbol? Anyone? Alpha. Yes. Omega is what? Omega. In case of rotational motion, what is omega? What is omega? Yes, correct. So that is angular velocity. This is angular acceleration. Okay, and just like F equal to ma, that is valid for linear motion. So here, tau equal to or t equal to I alpha. That is there. That's why actually ultimately that is required. That's why we are finding out this I alpha. Okay, so that is the case. Otherwise, we are just not randomly using, suppose finding out whatever I can find. Okay, so now whenever we are talking about Hooke's joint, right? Okay, or your Hooke's joint. So now there is a condition for maximum angular velocity in case of Hooke's joint. That is a standard expression which directly could be used. So that is cos of 2 alpha equal to 2 sin square alpha divided by 2 minus sin square alpha. So here this alpha, this one, and whatever I am saying right now here, these two are different. Okay, right now with this alpha, actually that's why we should write. Okay, this is the angle of intersection. Okay, this is the angle we are talking about. Okay, we are denoting it, and this angle we are talking about here. Okay, it is not the acceleration, but okay, understood with respect to the condition. And this alpha that we are talking about, okay, that's why we should use some other expression here if we can. Okay, so here this is the angular acceleration we are talking about in case of the final that expression. Okay, this is angular, sorry, angular acceleration. Okay. So now, using this example relationship, that is cos 2 theta equal to sine square alpha divided by 2 minus sine square alpha. So alpha equal to 20 degrees. So we are just putting that value. So what we have obtained, cos 2 alpha equal to 2 theta equal to 0.1242. So from here, cos inverse of if you just take this one, so 2 theta equal to 82.86 degrees. So from here, theta equal to 41.43 degrees. Okay, so theta angle, that is the angle turned by the driving shaft, that is obtained. Okay, so now up to this much, is it okay? Anyone, let me know, all of you are following me or not?
Yes, sir.
Okay, thank you. So now, what we can know once again, just like another expression that we can obtain. So now the maximum angular acceleration for the driven shaft. So this expression directly you can use, or you can keep on deducing also. That is up to you. So if you can recall, that will be easy for you to, so that directly you can utilize it. Okay. So now, here finding, we have found out theta. Ultimately, this theta will be required here in the case of finding out when we are going to find out the maximum angular acceleration for difference. So I can, we are writing alpha max. Yeah, that is the maximum value for the suffix max for maximum angular acceleration, and suffix 2 is for 2 denotes driving or driven. Suffix 1 is for driven driving sub. Suffix 2 is for driven sub. Okay, this is for driven sub. That's why 2. Okay. So that I can write like d omega 2 by dt, just like all of you already know. First derivative of velocity with respect to time. Okay, if you know about this, I think a equal to dv dt, you know, right? In case of linear velocity, linear motion, acceleration equal to derivative of what with respect to time. Okay, so similar is the case if you go for angular acceleration, a will be replaced by alpha, p is replaced by that omega. Okay, and this is for your driven sub, that's why it is suffix 2. Okay, so d omega t dt we can write like, this is the known expression, minus omega 1 square into cos alpha into sine 2 theta into sine square alpha divided by 1 minus, once or twice if you just practice this kind of problem, this expression you will be able to, all of you will be able to recall. Okay, there will not be any problem with that. Right now you might be thinking, suppose from where it is coming, and also directly this square and within this box whatever is being written, so directly this expression can be utilized. Okay, so now this omega 1 already we have found out to be 157. Okay, that is already there, this one. Okay, next, alpha, that this is the angle we are talking about. Okay, this is the angle, and this is what the acceleration, angular acceleration. Okay, that we are talking about. Okay, this is the angular acceleration. Okay, so they are not the same, don't get confused. Okay, so this alpha to be 20 degree, already we know in angle of intersection. Okay, that was 180 degree minus 160 degree, coming to be 20 degree. And 2 theta, just now we already have 2 theta value, directly we can put. Okay, or theta into 2 also you can do, no problem. As well as alpha, once again we are just putting, so other things are, these are known. So just by putting what we have obtained, so we are getting d omega 2 dt, that is the angular acceleration. We are replacing alpha with this so that we don't get confused, same thing. Okay, to be minus 3080 radian per second square. This is the angular acceleration that we are talking about. So this negative sign, don't get confused with the negative. So basically negative sign gives you the like can say directional sense. Okay, so that indication gives you. So now, as we now have that alpha value also, okay, maximum angular acceleration we have. Okay, so we have I value already found out by mk square. We know about alpha, that is required for your alpha 2, that is the alpha for driven sub. Okay, that is what is required. So I and alpha both are there, then we will be able to find out the torque. Okay, so the maximum torque for driven sub, I can write t equal to I into alpha max for the driven sub. Okay, so if I take the maximum value of alpha, then I get the maximum value of torque. Okay, we I same. So that's why after that, just by putting I into alpha is nothing but the, I can write alpha 2 equal to d omega 2 by dt. Okay, and this value is already given, so modulus value we are taking the one only. Okay, and this is the value of torque. So unit is in Newton meter. So with this basically this problem is over. Okay. Now, what are the main things that you must know here? So that means the angle you should be able to find out. You should, even just you are being looped by this 160-degree word. Okay, you should know that this hook joint itself is made for basically small angular deviation. 160-degree, that kind of thing, it cannot. So this was the included angle between the shafts. Okay, this angle, and actually the angle of intersection is 180 degree minus 160 degree. So the suffix n1 or omega 1 and 2, that I must remember. 1 and 1 for driving, 2 for driven. Next, whatever is given, just find out, get those things done. Okay, and you should recall the this and like standard expression you should be able to use, and some of the already used previous expression like I equal to mk square, those things. Okay, p equal to like alpha equal to d omega dt, those things you just use. Okay. Sir. So
Okay, so if you have any, just let me know whether you have understood or not.
sir.
Yes, sir.
Understood, sir. Okay. So this kind of problem,
Sir.
okay, this kind of problem from any book you also, okay, you try it, okay. Some of this
Sir,
kind of
for the
similar relation,
maximum
okay,
torque
Hooke's joint
T
problem.
equals to T alpha, what is that, sir?
Which one?
Sir, T I alpha suffix, sir. What it is written, sir?
This one, with red mark.
Yes, sir.
This is T torque. This is torque expression for torque.
Not that
T
one.
equal
No.
to.
Okay.
This is a known one, na? Just like F equal to ma. You know. This is somewhere written or you already know. Somewhere it is written in Principia Mathematics or something like that in the
Sir, I am
Newton's book.
asking that one, sir.
Okay.
Mm,
Hmm?
Maximum torque T equals to I alpha suffix M driven, sir. That one.
Yes, this is driven. Yes, driven. It is. We are talking about the maximum torque of driven stuff, right? So we have to take the maximum value of the driven only. This denotation for your understanding purpose. That means alpha for which one we are talking about. Alpha
Okay, sir.
maximum of driven we have taken. Okay, and otherwise this expression is known. So that means you cannot like if you think of maximum torque for the driven shaft, and if you take the maximum value of alpha, that is the angular acceleration for the driving shaft, then it will not be proper, na? So this is, if this is the driving we are talking about, then we have to go for the driving here. If you are talking about the driven one, torque for the driven, we have to go for the driven one. Understood?
Yes.
Okay. So this is the, so this kind of problem, okay, some other problem for hook joint or universal joint, whatever you call it, okay, you just try to find out, okay. Then one small problem we'll try to check from the steering gear mechanism. All of you already understand, okay. That means, like there was one expression for correct steering, okay. Condition for correct steering, that was the cot phi minus cot of theta equal to A by B. Yes, that you recall. Yes or no? That steering gear mechanism problem.
Yes, sir.
Okay. Yes, here itself it is there now. Okay, we have seen that basically these two angles, that is the angle, this is the theta is the angle made by the inner front wheel while taking the turn, and phi is the angle made by the outer front. This is right, now we are talking about right turn. If this is left turn, then it will be different once again. Okay, so but the thing is the theta is, that means the generally theta is the inner wheel has to rotate by some more angle. Yes, we have already discussed the thing. Okay, so now for that we have said that basically two type of steering gear, that is driving steering gear and Ackerman steering gear that we are using. Okay, so out of these two, which one was better, Davis or Ackerman? So Davis steering gear, it has got what, sliding pairs. Okay, because of that it was more wear and tear was there. Okay, so this is for theta is for inner front wheel. So in that case, and another thing, in case of Ackerman steering gear mechanism, the whole mechanism is situated towards the inside of the front wheel, so extra space is not required. Apart from that, that sliding pair problem was not there. Everything was turning pair in case of Ackerman steering gear mechanism. So because these are the two main reasons because of which we prefer which steering gear mechanism over which.
Sir, you are not audible.
Yeah, right now I am not saying anything. I am asking you the question. I am just waiting for your response. Which steering gear mechanism we prefer over which? That means Ackerman steering gear mechanism we generally prefer over Davis steering gear, or Davis we prefer over Ackerman steering gear. All of you have heard me, right? You can hear me?
Yes, sir.
Yes,
Can you
sir.
hear me?
Yes.
Yes. Okay. So generally we prefer the Ackerman steering gear over the Davis steering gear because of these two this you can say advantages that we gain by using Ackerman. Okay, so this does it. So right now I am showing you like this is the expression, that is cot phi minus cot theta equal to a by b. This is the equation for correct steering. Okay, this is the equation for correct steering, and this equation if it fulfills, then basically the whatever is your vehicle is taking the turn properly. So you can think of like there will be point line contact between the tire of the vehicle with the surface or the ground on which it is flying. Okay, and thus it is the wear and tear also is somewhat minimized. And apart from that, because of the stub axle, that is the smaller axle that was there, okay, we could have like we can get these two angles, okay, outer inner wheel angle and inner front wheel and outer front wheel angles, which has to be different. And generally we have seen that this inner front wheel, it has to get turned by or rotated by somewhat more angle, okay, but compared to the outer front wheel angle, okay, that is being turned. And a and b, a is the distance between the two pivots between the front wheels, okay, front side, and b is nothing but the, you can say, the wheel base, that is if this is the front wheel and this is the back wheel, so this is b. If this is the whole car, okay, so that's the thing, this is the b fellow. Okay, so this now we know what are the terminologies and all, and we are going to use it. So the question is the wheelbase and the width of the front axle in case of a steering mechanism are given as 2 meter and 0.88 meter respectively. Okay, that means what is given, a and b are given. So what is a wheelbase means this particular thing, this one, okay, wheelbase. So wheelbase is given b, okay, b is 2 meter, and front axle, width of the front axle, that is this, okay, so here to here this is given as 0.88 meter, okay. Now at an instant when the front inner wheel is turned by 18 degrees, so inner front wheel means that theta is given. So in your case you just don't write only given a equal to this, b equal to this, try to write down suppose even inner angle turned by inner front wheel equal to theta equal to this, like that, okay. So this is 18 degree, and they are asking that when they actually inner front wheel is making and turning by 18 degree, what should be the angle turned by the outer front wheel in case of perfect steering? We are talking about perfect steering. Okay, so now if it is perfect steering that we are talking about, then it has to, the equation for correct steering should hold good. Okay, so now we know about a and b, we know about theta, we don't know what is phi, that is the angle turned by the outer front wheel, we don't know. But what we do know is, we know that there is a particular relationship, standard relationship for correct steering. If the vehicle has to turn properly when it has turned 18 degree by the inner front wheel, then there is a standard angle by which the outer front wheel also should move. Okay, and that relationship is this: cot phi minus cot theta equal to a by b. So now as we know already this, so out of the four unknowns, three are already given, so I can just put it. So phi equal to and theta phi I don't know. Okay, I should be able to find out. So cot of phi minus cot of theta equal to 18 degree. A is 0.88 divided by b equal to 2 meter. Okay, so from here we have obtained cot of theta to be 3.518, and from here theta equal to 15.9 degree. So the outer front wheel should turn by 15.9 degrees. So this kind of sometimes small problems might be asked. Okay, so just use the equation for correct steering, you'll be able to find out the sum of the thing. And you should be able to find out which one is A, which one is B, like that. And try one or two problems from Davis steering gear or something like that. Or maybe I will try another one. So this one you have understood, right? Just by directly you have just used the values. Any confusion here? No. Okay. So another problem we'll just see from that is that was only from standard steering gear mechanism. Now this is particular to Davis steering gear mechanism. Just see. Okay. So we know that basically Davis, in the Davis steering gear mechanism, all those track arm etc. also were there. Okay. So now here is said that the track arm of Davis steering gear is at a distance of 192 mm from the front main axle. That is the edge value is given. That small edge value, if you can recall those diagrams. So edge value is given. Okay, whereas the difference between their length is 96 meter. Okay, so that is also given. So if the distance between steering pivots of the main axle is 1.4 meter, maybe you can do one thing. You'll just by all of you can write down this particular problem statement, and you try to solve it. Okay, in the next class we'll see. Okay, you'll write down the problem statement. And for how to solve, once again, like, you should be able to find out a b etc. And apart from that, the here the age value it will be required. Similarly, the how much movement was there. Okay, just try to check with the, already the slides are already provided, so they are in the Davis steering gear. Okay, whatever is there. Okay, so try to correlate those given data with that. So write down the problem statement. The track arm of a Davis steering gear is at a distance of 192 millimeter from the front main axle, whereas the difference between their lengths is 96 millimeter. If the distance between steering pivot of the main axle is 1.4 meter, find out the length of the chassis between the front and the rear wheels. You also need to find out the inclination of the track arms. Okay, that is, the track arm is nothing but the cross link to the longitudinal axis of the vehicle. Okay, so in those cases we have already seen those alpha angles, what was that was making with the vertical, which one is making with the vertical or horizontal, is has to be careful about that. Okay, so this is your exam, this is your homework. And maybe I'll just repeat one of the another thing that is important thing, to finding out the degree of freedom of any mechanism. So up to this much I hope that's clear. Yes, let me know. Okay, thank you. So previously you have done solve problems for finding out the degree of freedom of mechanism. Do you recall? Just so that you don't forget it, I am just taking one last example, okay, prior to finishing this module. So maybe let's consider this. So what I have told you, what are the steps involved for finding out degree of freedom of a given mechanism? First, you need to whatever is the configuration diagram that is given, you need to draw that. Okay, and if you can recall this expression, that is effective degree of freedom equal to, if it is a planar mechanism, it is 3 whole into n minus 1 minus 2p1 minus p2 into, if there is any redundant degree of freedom is there, that also needs to be eliminated. So this is the standard way of finding out degree of freedom for a planar mechanism. So now at first whenever it is given, so for your in your level we'll be dealing with planar mechanism only, so you don't have to worry about that. So this equation will hold good. So now the thing is, once you have the configuration diagram, after that you should be able to find out this n. Okay, this n is required, that is the number of links. Next, this p1, that is the what pair? P1 is lower pair or higher pair? Lower pair or higher pair? P1, the lower pair. Okay, so p2 is higher pair. So lower pair means what kind of contact? Surface contact or point contact? Point or line or surface contact?
But lower
What
pressure
kind of?
joint, no sir, work joints.
Yeah, I am talking about that only. So lower pair means what kind of contact? Yeah, we'll go through the joints only. Yes, for finding out the number of pair. Okay, lower pair. We'll go through the method of joints. Okay, that means we'll check
Surface
what kind of joint. Hmm? But what is the meaning of lower pair? That I am asking. What type of contact?
contact.
Surface contact. Yes, correct. Surface contact. Correct. So now in that particular case, this generally once those hinges also they also makes lower pair only. So first and foremost thing, first we should be able to find out the different links. Okay, for that we all those guides or ground links we give it the same number. That is one important task. Okay, so these are all one. Okay, these are all ones. Okay, and after that sequentially we have to keep on giving the numbers to the all those different links. Okay, sometimes a link may be something like this. Okay, the whole link may be a single link even though it looks like a kind of triangle, but that is ternary link. So that kind of situation also might be there. Sometimes just like this we can also have slider etc in between, there will be pin join. Okay, so all those things. So for finding out that we can go through whether it's what kind of joint it is, and in this particular case as you can see here, the shape of the link is such. Okay, it is not like from here to here one link, from here to here another link, but the shape of the link is such only. Okay, so that's why you should not give this link as another number, this link as another number. You can see here itself. Okay, it is shown that it is the similar way it is coming. Okay, so maybe this is link 2, this whole thing is link 3. Okay, then this slider is link 4, this particular link is link 5. And where do people make mistake? One is portion of making mistake, or possibility of making mistake is here. That means giving two different link numbers for this one, and another portion is you might forget to give link number to either the slider or the guide. Okay, so 5 is this, 6 is the slider which is in between here. Okay, because we have got pin joint here, and wherever it is moving, that is once again that is another guide that is there. Okay, if you don't give number to this, once again while finding out whether it's what type of joint, okay, ternary or binary, you will be missing out. Okay, similarly this one another link 7, and this portion is another link 8. Okay, so n is 8. Just find out whether binary or ternary joint, what kind of thing. So we have got 5 binary joints, we have got 2 ternary joints here. Okay, check. Okay, how many links are joined at a particular location, and after that for finding out p1, we know that for binary joint, so equivalent binary pair is itself is one joint gives rise to one binary joint gives rise to one pair. Okay, this is, if this is a binary joint, the pair is one joint one pair, one binary joint equivalent to one pair. Okay, lower pair. So but if it is ternary joint or quaternary joint, we knew that if it is ternary joint, so it is equivalent to 2 pairs. Okay, binary pairs. Quaternary joint equivalent to 3 binary joints, so like that. Okay, so that's why for binary joint is directly binary joint plus, for 2 then ternary joints we have 2 plus 2 under 4, 5 plus 4 equal to 9. Okay, redundancy is not there, fr equal to 0, higher pair is not there, p2 equal to 0. Just by putting we get degree of freedom to be. So now here is you have seen that sometimes it may so happen that degree of freedom may be more than one also. Okay, so these are some complex programming modules. Okay, so with this basically we have completed this whole module itself. If you have any question, any doubt, you can ask, or if you have understood or not, you can let me know. You need to do some solving problem. Okay, you should try solving some problems by your own. Okay, otherwise you will find. Okay, then I hope you have understood. So respond to your name calls. Nirutpal, absent. Shankar,
Present, sir.
Arsisman,
Present, sir.
Rehan,
Present, sir.
Partha Patir,
Present, sir.
Rishikesh Basumotari,
Present, sir.
Fermiki,
Present, sir.
Nohosol, Nohosol, absent. Theza,
Present, sir.
Rishikesh Nath, Rishikesh Nath, absent. And Emil.
Present, sir.
Okay, so thank you everyone. So we meet in the next class. So with this, this is over. Okay,
Thank you, sir.
I'll be supplying those material in the Google Classroom also. All those materials, whatever is not given, most of the things are already given. Okay, check your Google Classroom regularly.
Okay, sir. Thank you, sir.